Welcome students of class 12. We are discussing on the P block elements and specifically it is the group 17 elements. Before today's class we have discussed on the major part of group 17 elements, that is about the oxides of the and oxoacids, and in the previous classes we have discussed on the different compounds of and its uses of the halides. Now in today's class we should discuss on the metal halides, that is metal halides. We know that metals, that is calcium chloride, sodium chloride, these are formed, lead chloride, PbCl2, PbCl4, and metal halides are formed in different oxidation state of metal. So metal halides is the topic. Metal halides. Now as the group 1 and group 2 elements, as there is large electronegativity difference with the halides with group 1 and group 2 elements, these are basically ionic in nature, and with the P block elements it is generally covalent in nature. Now as their different oxidation state of metal is used to compound the halide, to form the halides, that is example PbCl2, PbCl4. So here it is in +2 and it is in +4 oxidation state. So different oxidation state is used. Now the question is, what is more ionic, or what is which one is more ionic or which one is more covalent? We have to identify. Now from the Fajan's rule we know that as the cation is more penetrating, or cation having the large positive charge on it, it can easily polarize an anion. As the charge on the cation is heavy, so it can polarize an anion, and expected valency is the covalency. So here we should expect from the Fajan's rule that here PbCl4 is more covalent than that of the PbCl2. So the questions are, there are different questions, that is PbCl4 is more covalent than PbCl2. Why? Another one may be SnCl4 and SnCl2. Here also +4 and +2. So in SnCl4 it is more covalent. Another one it is that of antimony, SbCl5 and SbCl3. Here it is in +5 oxidation state, it is in +3 oxidation state. So expected it is more covalent. Here also most covalent, and this one is most covalent. So the question is, why PbCl2 is less covalent or more ionic than that of the PbCl4? So we should explain it by using the Fajan's rule. Next one, that is interhalogen compounds. Interhalogen compounds. Now interhalogen compound, from the name, that is when an halogen atom forms a bond with another one halogen atom, then it is known as interhalogen compounds. It is represented as X dash N, where N may be 1, 3, 5, 7, etc. N equal to 1, 3, 5, 7, etc. Now X dash 3, X dash 5, X dash 7. So first of all X dash 1. Well, the example is ClF, BrF, etc. ClF, BrF, ICl, IBr. These are the example of X dash type. X3, that is ClF3, BrF3. These are the examples of X dash 3. ICl5, BrCl5, IF7. Compounds with XX-7 is rare, that is IF7, and for IXX-5 that is ICl3, BrCl5, etc. The examples of these are the examples of interhalogen compound. Now goes with some preparation of interhalogen compound. Preparation of interhalogen. Preparation of interhalogen compound. Here different reaction condition is required to react in between them, where somewhere it is the equal volume of the reactants, somewhere it is some of the temperature is the factor which is required to the reaction. First of all, it is Cl2 plus F2 forming 2ClF. Here the condition, that is force 37 K, that is temperature is the condition here. Another one may be I2 plus Cl2, that is 2 ICl. It is in equal volume of I2 and Cl2 reacts to form ICl. Another one, when polyatomic, that is Br2 plus 3F2, Br2 plus 3F2 forming 2 Brf3, Br2 plus 3F2 to Brf3, and Br2 plus 5F2, Br2 plus 5F2 forming 2 Brf5. Here excess of fluorine is required for the reaction. So it is some of the reactions to form interhalogen compounds. They react directly with one halogen with another one halogen, but the reaction condition, it may be heat or the volume. Next one, shape of the interhalogen compounds. We can predict the shape by using the VSEPR rule. Shape of interhalogen. We have already done it on the chemical bonding of class 11, that is ClF3. So first of all, calculate the overall number, total number of electrons. Cl having 7 electrons and fluorine having 3 electrons, so 10 electrons. Now 10 electron, that is 5 electron pair. Now there is 3 bond, so 3 bond pair and 2 lone pair, so it is of T-shaped. So this is T-shape. Brf5, here also 7 plus 5, that is 12 electron, but 5 bond pair and 1 lone pair forming square pyramid. So ClF3 is T-shape, Brf5, and IF7. What is the shape of IF7? IF7, it is pentagonal bipyramid. Pentagonal bipyramid. So by using the easy rules from the VSEPR theory, we can predict the shape of interhalogen compounds. Next, that is thermal stability of the interhalogens, specifically that is XX- type. Thermal stability of XX- type, that is ICl, IBr, IF. So the stability of the interhalogen compounds of the type XX- depends on the electronegativity difference of the interhalogen atom. As the electronegativity difference is greater, it is more ionic and it will produce the more stability towards the heat, etc. So it is the stability depends on the electronegativity difference of the two atoms. Now the example, that is, if we compare IF ClF ICl, IBr and BrCl. Now fluorine has a maximum electronegativity of 4. Fluorine, here the electronegativity of fluorine is 3. Br, that is 2.8. Iodine, that is 2.5, etc. Now if we see the difference between electronegativity, then the stability is in the order of that. That is, as the electronegativity difference is higher in between the two atoms, it is more stable due to the ionic character of the compound. Ionic character of the compound. As the ionic character of compound is greater, it is more stable. Next one is the some important compounds of group 17 elements. We have to discuss on the chlorine, that is chlorine gas, and HCl molecule. Now chlorine is a greenish yellow gas, Cl2. It is a greenish yellow gas and it is produced in different ways. That is, the laboratory use is the MnO2 4HCl. MnO2 plus 4HCl, that is MnCl2 plus Cl2 plus H2O, 2H2O. It is the laboratory preparation of chlorine gas. But industrial use of here, it is produced as a byproduct in production of NaOH from concentrated brine solution. So it is produced as a byproduct in the production of sodium hydroxide from concentrated brine solution. It is number 1. Second one, in the preparation of sodium from NaCl solution. So these are the two preparation of chlorine in the industrial scale. So the reaction of chlorine, second one, that is reaction of chlorine. First will metal and non-metal. Next, reactions of chlorine. Now first of all, metal, that is Na plus Cl2 forming twice NaCl. It is the formation of an ionic compound. Second one, that is when it reacts with water, H2O plus Cl2, then as it is oxidizing in nature, so it will oxidize the water. That means it will produce HCl NO2 plus O2. The balancing factor is 4HCl plus O2. So it will oxidize, as it is of oxidizing nature, it will oxidize the water. Next one, it is a very important reaction, that is production of bleaching powder or calcium oxychloride. Calcium oxychloride, the formula is CaOClCl. When calcium hydroxide reacts with chlorine, calcium hydroxide reacts with chlorine, it will produce calcium oxychloride. CaOClCl2 plus CaCl2 plus H2O. Here is CaCl2 plus chlorine. The balancing factor is CaOH whole twice, 2I Ca whole twice, 2I CaCl2 producing 2H2O. It is the balanced chemical equation. It is the bleaching powder. So when calcium chlorine gas, dry chlorine gas passed over the calcium hydroxide solution, it will produce bleaching powder. And another one reaction, it may be NaOH plus Cl2, it will produce NaCl plus NaOCl. NaCl plus NaOCl plus H2O. So it is sodium chloride, it is sodium oxychloride and water. Here also a types of reactions shown like chlorine gas. Next one is the oxidizing nature of chlorine gas. So in acidic medium, chlorine will oxidize ferrous sulfate to ferric sulfate, and it also oxidizes SO2 to H2SO4, sulfide to sulfates, etc. So what is the oxidizing nature of chlorine? In the acidic medium, it will oxidize ferrous sulfate to oxidizing character of chlorine. FeSO4 plus H2SO4 plus Cl2 Fe2SO4 whole thrice plus chlorine will produce HCl. The balancing factor is 2FeSO4 plus H2SO4 plus Cl2 Fe2SO4 whole thrice plus 2HCl. So here iron is oxidized. This is the example of oxidation reaction. And the another one oxidizing reactions are sulfur to sulfur dioxide, etc. Now next one is the uses of this, that is uses of chlorine gas or the uses of halides. So first of all, the fluorine used as an insecticide in the agricultural use. Chlorine also used as an insecticide or preparation of different fertilizers, etc., or the poisons for use in the agricultural field. Next one is the bleaching action of chlorine is used in the paper industry or in the cotton industry. Second one is bromine. Bromine is used in the industrial use and preparation of different chemicals, etc., is the use of bromine. Iodine having use in the human body also, and iodine is used to produce tincture of iodine. Tincture iodine is a solution of iodine and Ki in alcohol. And another one may be iodine isotope is used to trace the brain tumor. Next one, compound, that is HCl. Next one, that is hydrogen chloride. Now hydrogen chloride and hydrochloric acid are different. Hydrogen chloride is gaseous in nature and hydrochloric acid is liquid. When HCl gas dissolves in water, HCl having a higher tendency to form soluble in water, then it will produce this, and due to this it is of higher active because hydrogen water molecule abstract proton from the HCl. Next one, that is the preparation of HCl, that is NaCl plus H2SO4 NaHSO4 plus HCl. NaCl plus H2SO4 equal to NaHSO4 plus HCl. Now here HCl or H2O acts as a Bronsted-Lowry acid-base concept. Reaction of HCl, we know the reaction, that is it reacts with carbonates and sulfides to produce the gases like carbon dioxide, sulfur dioxides, etc. Uses of HCl, the HCl is very important lab reagent. It is used as an to produce different gases and etc., and also in oxidizing or oxidation reduction reaction This is all about group 17 elements. On the next day we will discuss on the group 18 element. Thank you.